All right, so let's talk about the questions here. Okay, again, look at the point values as an indicator for how much work is going to be involved, and know that you will very, very frequently be using the constants on the back of your formula sheet. Average Earth-Moon distance, Earth-Sun distance, mass of the sun, mass of the moon, mass of the Earth. Okay, you're going to be using that a lot. Okay, so for question number 1, okay, they're telling you how far Jupiter is from the sun, and they're giving you Jupiter's mass, and they're simply asking what the force of gravity due to the interaction between Jupiter and the sun would be. Okay, so you're just looking for a force of gravity on number 1. Okay, for number 2, there's more than one way to do question number 2. Okay, either way is fine if you figure out the second way. Sometimes people do. Okay, it does tell you that Uranus requires 84 years to circle the sun, and they are giving you the mass of Uranus. Okay, find the orbital radius. Okay, as I said, more than one way to do that. And remember that Uranus does in fact orbit or circle the sun. Okay, number 3, similar question. Okay, Venus has an orbital period of revolution of 225 Earth days, and the distance between the sun and Venus is 1.08 times 10 to the 11. You're looking for the orbital speed of Venus, which, remember, orbits the sun. Okay? All right. Guys, a lot of these are giving you the orbital periods in units other than seconds. Keep that in mind. Okay? All right. Number 4 is talking about the Cavendish experiment. We watched the video of the guy that built that with 2 bowling balls and those masses on a ruler. Okay, so it's just like that setup. Okay, but they're saying that the large lead ball, so that would be in place of the bowling ball, has a mass of 5.9 kilograms, and the small one has a mass of 0.047 kilograms, and they are 0.055 meters apart. You're just looking for the force of attraction between them. Don't overthink it. Okay. Number 5, a little bit of a trick in that one, so be aware. Okay, you are looking for the gravitational force between 2 electrons. Okay, that are a meter apart. Okay, now imagine electrons are pretty small. Okay, they're a meter apart, and their gravitational force between them is 5.54 times 10 to the minus 71 newtons. Okay, they are not attracted to each other very much. Okay, I want you to find the mass of an electron. Okay, using those numbers. The thing to remember here is that all electrons are identical. Okay. All right, number 6. Mimas, which is a moon of Saturn, has an orbital radius of 1.87 times 10 to the 8 meters and an orbital period of 23 hours. Find the mass of Saturn, okay, using those numbers. Okay, for number 7, we are talking about Apollo 2's orbit. Okay, they adjusted it to 111 kilometers. The radius of the moon is 1,785 kilometers. So I want you in this question to think about where that 111 kilometers is likely measured from, given that the radius of the moon is 1,785 meters. Okay, kind of an important thing that people overlook in that question. Okay, and of course you are given the mass of the moon. Use that mass, not the one on your formula sheet that has an additional number. Okay, so for part A, looking for how many minutes it took to orbit the moon. Minutes, not seconds. Okay, and we're also looking for the velocity that it was orbiting the moon at. Okay, number 8. A spy satellite has an orbital radius of 2 Earth radii. It's also orbiting Earth, as we don't spy on anybody else. Okay, I often get people, well, what is it orbiting? Earth. We don't spy anywhere else. Okay, its period, what we're just looking for is period of revolution. Okay, and then for number 9, okay, it's about Mars and its 2 moons. Okay, and they're giving you some information about each one and just asking you to calculate something else. Okay, so orbital speed for each of Mars's moons, which incidentally orbit in different directions. Okay, and then for number 10. Number 10 is probably the most work. Okay, it is a net gravitational force question. Right? You are looking for the net gravitational force on mass 1 due to its interactions with masses 2, 3, and 4. The one thing I will point out, because people get this wrong, this is a square. So this side is 1 meter. And this side is 1 meter. This is not 1 meter. I often have people say that it is. Okay? That is clearly further than 1 meter if the sides of the square are 1 meter. You laugh, but people make that mistake all the time. Okay? All right. And then for number 11, okay, you just have an asteroid. You're given the orbital radius. You're given its mass, period of rotation around the sun. There's a lot of satellite stuff on here, obviously. Okay. Number 12, okay, Saturn's. You're given Saturn's equatorial radius. You're also given its mass. They want you to find the acceleration due to gravity at the equator. Okay? And tell me how many times greater your weight would be on Saturn than on Earth. The answer may surprise you. Okay? And number 13, okay, again, you've got two masses, you're told how far apart they are, okay? You're looking for the gravitational attractive force between them. Okay, questions? All right, you got the rest of class to work on this. I am going to make it due this Friday. Okay, so you need to bring it to me this Friday.
You're allowed to look at your answers.
I would like you to do as much of this on your own as you can, because it is supposed to be assessing what you know and not what you can collectively figure out. That said, I can't really stop you from working with other people outside the class. But, yeah. If you want it to be an indicator of how much you know,